So I was planning on doing this really cool experiment with my science club students to demonstrate the property of polarity. It works by putting a coffee filter in a glass with a different solvent. Here I have water and isopropanol as my two solvents. And then I drew on the coffee filters with either washable marker or permanent marker. And what you'll observe is that the washable marker will get pulled through the coffee filter by both the water and the isopropanol, but the permanent marker will not get pulled through the coffee filter by the water, but it will get pulled through by the isopropanol. And that happens because water is a polar substance, and so are washable markers. But permanent markers are a non-polar substance, and so is isopropanol. And while this is a really cool experiment, it took 45 minutes to see the results, and my second graders are not going to wait that long. So I designed a different experiment that still uses coffee filters, washable markers, permanent markers, water and isopropanol, but you can see the results much faster. So first I'm going to draw on two of my coffee filters using my washable marker. I'm just writing the word hi, but you could write whatever you would like. Then I'm going to do the same thing with my permanent marker. And again, I'm going to write the word hi. If you want to do a heart or a star or a dot like I did in the previous experiment, that's totally fine. Just make sure that you're consistent with what you're drawing on your filters so that you know the results you observe are due to the chemical reactions and not because of different pictures. The next thing that I'm going to do is add water to two of the filters. I'm going to add water to one of the filters that has washable marker on it. And then I'm going to add water to a filter that has permanent marker on it. And what we will observe is that the water will not wash away the permanent marker because water is a polar substance. It has a partial charge. And washable markers also have a partial charge. But permanent markers are nonpolar. They have no charge at all, and so water is not going to interact with them. However, isopropanol is also a nonpolar substance, and so it can act as a solvent for permanent markers and dissolve them away. And the companies that make these markers use a lot of chemistry to design these because they know that if you want a washable marker that you can clean off of your walls and tables, it needs to dissolve in water. And if you want a permanent marker that's not going to wash away when it gets wet, it needs to be a nonpolar substance that is not going to dissolve in water. And so what we'll look at here is how the water definitely washed away the washable marker. You can barely see where it says the word hi anymore. And we'll take a look at the next one, which is the water with permanent marker. And you can see that hi is still there, still clear. It did not get washed away by the water. As we look at washable marker with isopropanol, it does dissolve it a little bit. And that is because isopropanol actually has a polar component to it and a nonpolar component to it. But the nonpolar component also smeared that hi from the permanent marker. So hopefully you enjoyed this experiment and you could try either one of these. They're both super fun and super educational, and I hope that you get to try at least one, if not both of them. If you enjoyed this video, please like and subscribe so that we can continue bringing fun and educational, engaging experiments into the classroom and into your home. And you can also visit us on our website for more activities and free printables. Thank you so much, and until next time, keep discovering.